Good afternoon, everybody, and welcome back to iCar's Repairers Realm. I am Bud Center, Director of Technical Products here at iCar, and to my left I have
J.R. Lee with ProSpot International.
Jim Corus with Solid Equipment.
Jeff Koppas with Carliner.
Good afternoon, gentlemen, and thanks for joining us again. We had a previous episode that we recorded on GMA welders, and today we're here to talk a little bit about spot welders. So we'll kind of jump right into this topic again. And before we get really into this, let's make sure that I remember to tell everybody up front that if you have any questions on this episode, you can submit those questions to repairersrealm at i-car.com, and we'll get those questions over to these industry experts and get the response back to you as quickly as possible. So as we jump into this one, guys, let's talk a little bit about spot welders and what's changed. So we all remember the spot welders of old and how technology has changed, and now we have things like, fully automated and digital control and things like that. How have spot welders changed in the last few years that has really changed the way that a technician needs to understand the technology and use spot welders?
Reality-wise, they evolved, from the early 2000s when they started coming out. The air to over liquid cooling and stuff, the duty cycle, it's been a huge difference and game changer on how much you can use it and the amperages they produce, because the fact of the matter, the steels are changing. So the welders need to change. And that's kind of where we're going with that. So
a lot of machines now have auto mode. So once you calibrate the machine, it knows what zero resistance and zero thickness is. And when you go make your weld, it's going to sense all that and it's going to adjust for you and make the weld appropriate for that spot.
Just changes in the technology. So we went from our transformer machines. We had a large transformer in the machine. So now we have transformer guns, making them much more efficient on shop power and enabling us to get those higher amperages and the squeeze pressure that we need for modern welds.
So with these new machines, and really with even the older ones, how important is the power supply to these units? I'm sure we've all been in shops and you'll see two people hit the trigger to weld at the same time and the whole lights start to dim in the shop and things like that. What is that doing to the weld at the time that they're pulling the trigger?
If you're pulling amperage away from the machine off the wall, it's not going to perform the proper weld on it. So you're not going to have the current to make the weld. So making sure you have the right wire gauge to the plug and a sufficient supply there is critical to have a correct weld.
You really need the correct supply voltage. A lot of the welders, too, won't even work if it's not correct. Being in auto settings, it's requiring a certain amount. If it doesn't get it, it's not going to produce it. So, so that's one reason why you need that correct voltage.
Yeah, a lot of times if you're doing a new install of that, electricians will look at the ampacity of the welder. And because of how a welder works, it has a heavier draw. So the National Electrical Code, Article 613, refers to electric welders and recommends oversizing wiring, oversizing circuit protection, just to make sure that it's available. And again, the newer welders are more forgiving on the power, but you still don't want to starve it to begin with.
When you guys, this is more a question from my knowledge than probably anybody else, but when you guys sell a welder, do you go out to the shop and actually test the power supply to make sure they have the right power supply for the unit?
100%.
Because we have had failures where if a spray boost's running, it's drawing the amperage away and the machine won't perform properly, or actually will shut itself down too. So, yeah, we always try and assess what they have there and make sure they have sufficient power there.
A lot of times it's hard, sorry. It's just there's a shop here in Chicago. It was running ACs, boosts were running. The welder one day worked great, and the next day the voltage drop was killer. So you always got to check because these things do demand it.
Well, the next question I had for you guys is, if we look at the way that vehicles are built today, modern vehicles with all of the high-strength steels and mixed materials and things like that, how has that changed the game for spot welding and the technology in spot welding?
Well, the spot weld is similar to what the factory uses to manufacture the vehicle, and with all the high-strength steels, heat is its nemesis. So we have a smaller heat ring or heat source where we're doing it with a quality weld, and it's not degrading the metal as much. So
you're not killing the tensile strength, basically. Whereas you take a MIG or something like that to it, the heat ring really doubles. So
a lot of times they'll ask, okay, well, why do I need this new welder? Because it has this many amps. Can I use this one that's a little lower? The thing is the heat. So by having that higher amperage, we can do the work quicker, less chance of damaging that surrounding metal, and be able to save the tensile strength.
You mentioned something that I want to dig into a little deeper, because I get phone calls from shops frequently that are upset that some of the training that iCar has, spot welding training, requires them to have a spot welder. And I hear things like, my guys know how to weld. They can use a mag welder. We're good. We're okay with that. The manufacturers, they don't know everything. And I'm always trying to help people understand that you're changing the metallurgy. You're changing that metal. You've irreparably damaged that metal if you put a mag weld on there. But let's talk just a little bit about that. I mean, why is it so important, the heat effect zone?
So when we talk about like the ultra high strength steels and that, how they manufacture it is they're trapping those carbon molecules within the steel, and then they quench it to get them trapped there. And the problem with GMA welding is we have no way of cooling it like that. So as you heat it up, it's allowing that carbon to leach out. And while we've taken that ultra high strength, made it into basically a mild steel. And there's graphics that show you can physically see how it's changed the steel. Whereas the spot welder, because we're holding it under pressure and a controlled heat, we can maintain that. Less damage on the metal.
Dude, I mean, shop's same thing. The GMA welding's fine. We can get it. It's shipping them out the door, but unfortunately, you're not putting it back to the way the specifications OE wants.
I really hear that all the time. Well, my guys know how to weld. We're not saying they don't, but it's a different type of welding. It's creating a different heat effect zone, and it's a problem. And people need to understand that it's not just that we want you to have a different piece of equipment. It's required with these new metals.
Even though you've been doing it a certain way for 10, 15, 20 years, times are changing, not even yearly. It seems like monthly and weekly on how the cars are made. And you got to keep up with that. And part of that is having the correct equipment to do it.
We had somebody that was here at iCar that came from an OE that talked about vehicles that had to be purchased by a shop that repaired them because they had a squeak somewhere, and they got out a MIG torch and hit a couple of MIG welds on something that was ultra high strength steel. To solve it, they did solve the squeak problem, but now they just destroyed the vehicle because you can't fix that. So it's important. Let's talk a little bit now about some of the ways that these welders have changed. So we talk about how they're more automatic, they're more digitally controlled and things like that. What are some of the things that have actually changed with the machine that allow them to do these things? You have sensors and things like that. How's that working?
Absolutely. Controls, so the interface that the technician uses, have become more graphic. We're able to share more information so they know what they're doing. And then having that built in to where it recognizes the type of material, ranges of materials, and the thickness, and is able to set those for it. So it's made a huge impact in being able to do that kind of a weld.
Type of welds, right? We talked about how these machines are automatic, and we've done some testing on things. And can the technician always count on the fact that, hey, I've grabbed a piece of metal and I've done some test welds, not necessarily tested on metals that are same as on the vehicle? Can they be confident that it's going to weld, everything's going to be good, or do they still need to do destructive testing on the right type of metal?
Critical destructive on the metal that's on the car.
Yes.
I mean, you don't know. Most of the test coupons or anything else could be a different style of metal. Machines going to weld it differently. Destruction is going to be different. So doing your final test on something that came off the car, or the old panels or something of that nature, would be the best thing to do, just because you're using that metal and the density is the same and everything, the thickness is the same. You can use that to check to make sure that it's going to perform properly before you do it.
And you might have guessed there's a reason why I asked that, right? We go out into shops and see people just grabbing, sometimes they'll have coupons left over from an iCar training class, and they're using that for their test holes. I'm like, great, you're testing that the machine is working, but it's not the same as the material on the vehicle. You need to make sure. So doing all those things to make sure that that's right. What are some of the most critical factors for setting up these machines and making sure that they're functioning properly?
Just when you're doing, all of our machines have to be calibrated before you use them. And the calibration is checking for zero resistance, zero thickness, so that it can calculate when you're welding what the thickness and the density of the metal is. Making sure the caps are clean before you do that, to make sure that everything is calibrated properly. making sure that the fluids are in there, so everything's cooling properly. Just the general checklist of maintenance is huge before you even start welding.
A lot of times too, guys, under the calibration portion, like you're saying, they'll think that you have to put metal in between the caps, and that's a big no-no. We want no metal. Even if there's metal stuck to your caps, you need it cleaned off or replace them.
Part of the whole calibration process is the welder checking itself to make sure everything is in good shape, ready to start making welds. Like I said, clean caps and shape and everything like that. So it's important that we do that and pay attention to it. If you're getting a bad result on a check, then don't try and go past it. You need to clean up the machine, get it ready to weld.
So since you brought it up, let's talk about calibration while we're on this topic, right? So what is the machine doing when you're running through the self-calibration?
It's checking for zero resistance and zero thickness so that it has a baseline for when it's actually welding on the car. It can tell the density of the metal and the thickness of the metal to appropriately set your amperage, your squeeze, and your duration of the weld.
Okay. I hear techs all the time saying, well, I do this and I'll get through 15 welds and it wants me to calibrate again. Why?
Exactly. Again, we talked about that check. It's doing the same thing. Has anything changed through the course of this? Is my distance reading different now that it has to adjust from? Is my resistance now different? So doing that check every 30 welds or whatever the welder is set to, is the machine verifying that you're good to keep welding?
Or your tips haven't changed.
Right.
No, nothing's happened.
A lot of times we're welding for glue, so there could be glue on the tips, and that's going to change what the machine's reading. So you either clean them off or replace them again. But it's just a fail-safe to make sure the welder is properly performing his task.
So from your perspectives, being tech reps for these companies, what are some of the keys for technicians? What can they do to make sure that they're getting the best performance out of these type of welders and they're doing the right things to be as successful as they can be?
Preparation. A spot welder is not pneumatic vice grips. They need to set the machine or set their repair up correctly, make sure it's all prepped correctly, and then take care of the welder. Make sure that the caps are clean and to the right shape and the arms are clean and tight, and just
don't have to be fit right. They have to be fit right. I can't just squeeze it together with the tips on the machine.
These welders may have a lot of squeeze pressure, but they are not at vice grips. They act like that.
In that small split second where it's squeezing and checking all that, if it senses too much thickness because it's not together and it's actually trying to pull it together, it's going to get a false reading. And a lot of times you'll blow through because the machine's thinking it's thicker than it is because it's already, it's wider as it's clamping it together. So making sure that's clamped tight before you even do your weld is critical.
All right, so we've talked a little bit about the calibration, and just to make sure we're all on the same page and the users or listeners are on the same page, the difference between calibration today and what they've seen in the past, and is it more important or is it really the same with these computer controlled? I would think that it's more important that they stay on this with all the computer controls now, making sure it stays calibrated.
Yeah, as he mentioned, we have sensors in that are helping us determine the thickness and measure the resistance and that sort of thing. So that calibration part of the weld is important to making sure that it's all measuring everything correctly and machine set up correctly. So
the welder's it's going to weld. It's just you're kind of doing blindly, and it's not reading accurately. So without a calibration on these welders today, you're kind of just throwing stuff at a wall and see what's kind of going to stick. And so that's why it's so critical.
All right, so we've talked a little bit about the importance of tip maintenance and things like that, but let's dive into that just a little bit deeper. So what are some of the things that people need to make sure that they're maintaining on these machines to make sure that they're getting the best possible welds, but also how does that impact the lifespan of the machine if we're trying to weld through tips that are junk, or we're trying to weld through adhesive that's on these tips, and what is that doing to the, right, you get into different things, it's going to cause the machine to run hotter and things like that. What are some really important things for techs to understand about what can they do to make sure they're getting the best welds and make sure that you're maintaining the equipment so that it performs for a long period of time?
I think one of the biggest problems I see out there is where the arm actually engages into the gun. If they're not kept clean, whether it's dust from atmosphere in the dirty business that we do or whatever, the arm is actually making contact on the gun there, and that's where it's transferring its current. So if it's not clean, it's something as simple as taking a red scuff pad and maybe just cleaning it up and making it shiny inside the arm or inside the saddle or wherever the arm is engaging. Because that will create resistance. You're not going to get a quality weld out of it. And that's something it is consumable. But maintaining that on a regular basis is a simple way of just making sure the machine's going to perform properly.
They're pretty crucial a lot of times if the powder coating or whatever coating's on them wears off over a period of time. It's basically a positive and negative. The negative touches a part of the panel you don't want, it's going to arc out and cause more problems down the road. So simple things just to keep an eye on maintenance-wise on the arm side of it. So, yes.
So keep, I would say, clean and tight. So like the C-arm and the C-arm pocket, the receiver there. Ours is coated so we wouldn't scotch right, but keeping it clean so there's no dust or grease buildup. And then the caps. Just having bare copper isn't enough. You need to maintain the shape. The shape is important to the quality of the weld. That's why we see OEMs that define different cap sizes, because there's a specific thing that they're looking for. So technicians need to be maintaining the cap shape, either using a dresser or changing caps when they need to. It's going to make a huge difference in the quality of the weld.
Glad you brought that up, because I've run into many situations in shops where you go in and see them welding, putting spot welds on a vehicle, and you can tell by looking at it they've got the wrong caps. And there's so many techs that don't understand that different manufacturers require a different size cap. I mean, where can they? Is there somewhere on your websites or something that they can go to look at and say, hey, this manufacturer requires this style cap? I mean, I know it's in the repair procedures, but is there somewhere that they can go on your website and just see a list of everything that's available and what they should have?
I don't think our website has a vehicle specific.
We make caps for certain, but nothing specific on that portion of it.
Ours, like in the reference material, it does reference that style of cap and the OEM, at least the three main ones that are defining it.
So I think the last question I had for you guys today before we wrap this one up was just, as reps out there in the field and dealing with helping technicians and installing new equipment and things like that, what are the most common mistakes or issues that you're seeing technicians have out there in the field?
Mainly just training. I mean, as long as the tech is aware and we go in, we do our normal initial training and they understand the welder in front of them, it's usually not a problem, but training is a big key. I mean, as you guys know, you're in the training side of it as well, so it's one of those things where if you don't understand the product, it's going to be a hard thing to really take on. So,
see a lot of guys, I think our machines all probably do pretty much the same thing. It makes it pushes and does a pulse in two separate pulses on the machine when you're calibrating. A lot of guys will let off on the first one and not fully calibrate a machine and then go try and weld, and it's not working right. So they got to make sure that they're following, like you said, following procedures and how to calibrate the machine properly before they go and start welding. And just the other problem I see a lot of times is it's just not cleanliness where the contact tips are going to be. So you're having an issue where it's not making contact and you can't make the weld. Always make sure the contact tip areas where the machine is going to try and weld is always clean bare metal so that it can do its job and check the resistance and stuff. So.
And maintenance, keeping up on the machine, making sure, like I said, everything is clean, tight, shop has good air, proper air pressure, all those things, making sure all the arms are good. All that's going to play into how long the welder works and quality work you can do with it.
Well, gentlemen, thanks for joining us today. I think what we've talked about here today hopefully will help everyone understand that you hear all the time, spot welders, you just pull the trigger and it's done. But there are a lot of things that go into this and a lot of things that have to be, you have to consider and make sure are right to make sure it's performing right and you're getting the proper weld. So again, thanks for joining us and helping us help the industry understand these machines better. And again, for anybody who's watching, if you have any questions, please submit them to repairersrealm@i-car.com, and we'll get back to these industry experts and get you your answers as quickly as possible. Have a great day.
Thank you.